All right, guys, so in this video, I'm going to go through this problem right here. OR of x equals x on x minus 1 squared all over x plus 3 cubed. So what I'm going to do is I'm going to find the x and y intercepts. I'm going to find the vertical and horizontal asymptotes or oblique asymptotes if they're there. And then I'm going to graph that, and we're going to sort of get a feel for what this function actually looks like and the behavior of the function. Okay, so I'll start with the x and y intercepts. So I want the x-intercepts. I will say note first off that the function is already in reduced terms, as in there's no factor in the numerator and denominator that I can cancel. There's no common factor. So I'm already in reduced terms. So my x-intercept, to find my x-intercept, I'm going to let my function, OR of x, equal to 0. I'm going to solve. Okay, so I'm going to let my numerator equal to 0. So my numerator is x on x minus 1 squared. I'm going to let this equal to 0. Well, the solutions to this equation then are x is equal to 0 and x minus 1 squared is equal to 0. Well, x is equal to 0, that's one solution. And that tells me that my function must go through the origin. And x minus 1 squared is equal to 0. Well, therefore, x minus 1 is equal to 0, and therefore x is equal to 1. And that's my other x-intercept. And so my two values are, as an ordered pair, 0, 0, and 1, 0. Those are my two x-intercepts. All right, my y-intercept. In order to find that, I'm going to evaluate OR of 0. Evaluate OR of 0 to get my y-intercept. All right, so OR of 0 is equal to, just to remind myself of my function, it would be 0 on 0 minus 1 squared. 0 minus 1 squared all over 0 plus 3 cubed. And so that will be 0, I'll have a 0 up on top. And 3 cubed, 3 3s are 9, 3 9s are 27. And so I'm getting 0 over 27, which is 0. So my y-intercept is also 0. So my y-intercept is also 0. I could have worked that out from the fact that one of my x-intercepts was the origin. The fact that one of my x-intercepts was the origin would tell me that the y-intercept is also going to be 0, 0, and this here confirms that for us. All right, so I have my x-intercept, I have my y-intercept singular. I'll now go on and find my horizontal and vertical asymptotes. I'll start with my vertical asymptotes. So my vertical asymptote, I'm going to look at my denominator. And when is my denominator 0? Well, my denominator is x plus 3, all cubed. It's equal to 0. Well, if x plus 3 cubed is equal to 0, let x plus 3, the cube root of both sides, x plus 3 will be equal to 0. And therefore x will be equal to negative 3. And that is my vertical asymptote. X equals negative 3, and I just have one vertical asymptote at x equals negative 3. My horizontal asymptote, I am going to have a horizontal asymptote because my function, look at my function, up on top, I have an x minus 1 squared, so I have an x squared term multiplied by an x term. So that's going to give me an x cubed term. So my function up on top, my polynomial is cubic. In the denominator, I have x plus 3 cubed. Again, I'm going to have an x cubed term. Again, that's cubic. So I'm going to have an x cubed over an x cubed. So my function, my horizontal asymptote then, my OR of x is going to be x cubed x cubed plus whatever else all over x cubed plus whatever else follows. And so as x goes to positive and negative infinity, as x gets large in both directions, r of x is going to go to simply x cubed over x cubed, which is 1. And so I will have a horizontal asymptote at y equals 1. And so I have my horizontal asymptote. So I know my horizontal asymptote, I know my vertical asymptote, I know my x-intercepts, and I know my y-intercept. All right, so I'm going to now just graph my function and see if I can get a sense of what it will actually look like. We get a straight line here. Okay, so I'm going to go 1, 2, 3. I'm also going to graph this using a graphing utility. I'm going to just graph it here first so I can maybe get a sense of what it should look like. All right, so put in my asymptote. I have 1 at y is equal to 1, so I will have an asymptote here. It will be my horizontal asymptote. My vertical asymptote is at x equals -3, so that will have an asymptote here. And so those are my horizontal and vertical asymptotes. I'll put in my, a little bit bigger, I'll put in my x-intercepts and my y-intercept. Well, x and y-intercept is at the origin. I have one x-intercept there, and my other one was at 1. Just remind myself, yeah, x equals 1. And so that is going to be right there. And so those are my intercepts put in. All right, so now it only remains to work out what my function actually looks like. All right, what does my function actually look like? To do that, I'm going to look at the multiplicities on the factors in the numerator and the denominator. All right, so I'm going to start with the numerator. What I'll do is I'll rewrite r of x just down here, just so that we can refer to it easily. So r of x is x on x minus 1 squared all over x plus 3 cubed. Just convert this here. All right, so there's my function. And so what we notice, looking at the x-intercepts, for example, that the x-intercept at x equal to 0, the factor that gives rise to that x-intercept is this here, x to the first power. What that tells me, that odd multiplicity on the x, tells me that the function at that value is going to go through the x-axis. It's going to go through the x-axis at that value of x equals 0 at the origin. The factor x minus 1 is giving me this x-intercept at x equals 1. And that x minus 1 factor is raised to an even multiplicity of 2. That tells me, that even multiplicity tells me that the function is going to just touch the axis at that point. It's just going to touch it. It's not going to go through the axis at that point. So what I know then is that my graph, and if I also consider my asymptotes, now in particular my horizontal asymptote here, the behavior of the function as x increases to the right, my function will just touch the axis there at that point. It'll just touch it, come down, but it won't go through it at x equals 1. Again, that's because of that even multiplicity, that 2 on the x minus 1 factor. The fact that x minus 1 is raised to an even power. Whereas at 0 at the origin, it will go through. It will go through the x-axis at that point. And so I can complete my graph. It will look something like that at that area. And then to the right, well, I know that it will, as x gets large, my function will go off out here and it will approach that asymptote. So it'll go in that direction right there. And then down here, it's not going to cross back up. It's not going to cross the x-axis again. I only have two x-intercepts. And so my graph is just going to continue off down here. It's going to continue off down here. It's going to approach this vertical asymptote. It's going to go off to negative infinity in that direction. All right, so that's what the graph is roughly going to look like on the right-hand side of my vertical asymptote. So now I consider what the graph is going to look like on the left-hand side of the vertical asymptote. And to work that out, well, I look at the factor in the denominator. That x plus 3 factor is what's giving me that vertical asymptote at x equals minus 3. And the factor x plus 3 is raised to the power 3. 3 is an odd number. It's raised to an odd multiplicity. And what that means, is that the graph is going to go in opposite directions either side of that asymptote. That is to say, if it goes to negative infinity on the right-hand side of the asymptote, as it does in my particular function here in this question, then it will go to positive infinity on the left-hand side of that asymptote. So I know that this asymptote then must come in this direction, come down here on this side. And then of course we know then that it's going to follow that horizontal asymptote. And so this is giving us a feel for what our actual graph is going to look like. It's going to behave roughly in this fashion. And it is important that we understand how the multiplicities, both in the numerator and the denominator, on those factors, whether it be the factors that are giving us our x-intercepts or the factors that are giving us our vertical asymptotes, how the multiplicity on those factors determines the behavior of the function either at those x-intercepts or either side of those asymptotes. All right, so that's what I would expect roughly my function is going to look like. I can then, of course, just graph my function, and I've done that already. Let me just bring it up, and there we go. That's what my function looks like. And we can see that all in all, not bad. There we have the general sense of what it is doing. We see that it is on the right-hand side, it does go down to negative infinity as it approaches that vertical asymptote, and then it crosses the x-axis once, and then touches the x at the origin, and then touches the x-axis at the value of x equals 1. And then on the left-hand side, again, notice that because it's going to negative infinity to the right of that asymptote, well then to the left of this asymptote it's going to go to positive infinity. Again, that's because of that odd multiplicity on the x plus 3 factor. Right? It's raised to the third power. 3 is an odd number, and that's what's giving rise to the fact that it's going in opposite directions either side of that asymptote. And so that's how we go about using that information then to graph these, or graph a rational function in a sort of a quick way, and to understand, just generally speaking, how our graph is going to move. All right, that was helpful.